The last section of trig we're going to learn together is a more precise way to represent an angle. And this is called degrees, minutes, and seconds format. So if you had an angle that was 52 degrees, 52 degrees exact is a reasonable angle. If, however, the angle is not exact and it becomes a portion of the next angle, then you could write that as 52 point blah 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 degrees, or you can actually write it in a more formal format called minutes and seconds. So if I'm going to jump right in, 52 degrees, 28 minutes, 41 seconds, that's telling me that my angle has been divided up into a portion of a degree called a minute, and then a portion of a minute called a second. So we all know that a circle is based on 360 degrees. Each 1 degree can be divided up into 60 minutes. So that's 1 degree holds 60 minutes. And then each minute can be subdivided into 60 more sections called 60 seconds. So you can get very precise. Your job is going to be able to work back and forth between angles given in degrees and decimal values after, or angles given to you in degrees and minutes and seconds. So for example, if we have an angle represented as 52 degrees, 28 minutes and 41 seconds, how do we convert that into a decimal degree to let us know how much is it approximately? Very simple. You take your whole degree and you add to that the portion of the next degree that's made up of the minutes and made up of the seconds. So 28 minutes means 28 out of possible 60 minutes, which converts to, as a decimal, 28 divided by 60, 0.4666, repeating. 41 minutes means 41 seconds rather, 41 seconds out of the 60, and then out of the 60 again, because it's 60 seconds in a minute and 60 minutes in a degree. So we have to divide by the fact that it's 60 out of a 60, which is going to be 3,600 out of the whole degree. There's 60 minutes in 1 degree. There's 60 seconds in a minute. If you have 41 seconds, you have 41 out of 3,600 overall degrees, which works out to be as a decimal. Divide that up, very small number, 0.011388, and so on. If you add that number, which is the second portion, to the minute portion, to the whole degree, what you will get is 52.4780555. And that's overall degrees now. And that's a number that we worked with through all of the trig sections so far. It's just that it's a measurement in degrees that is unrounded. So it's almost 52.5 degrees, but not quite. And if you think back to what a minute is, it's 1/60th of a degree, and we have 28 minutes. The fact that it's 28 out of 60 means it's almost half. So it's almost half of another degree. So then, depending, if you did this calculation, and you had to find an angle in your question, and you were asked to give the answer in degrees, you'd be told how to round. So if I told you I want you to give me an angle to the nearest whole degree, the answer would be 52 degrees. if I asked you to give me the angle to the nearest tenths, you would need to round the nearest tenths, which would be 52 point, the 7 would round the 4 up, 52.5 degrees. If I asked you to round the nearest hundredths, then you would have to round the nearest hundredths position, which would be the 7th digit. 8 would round it up, so your angle would be 52.48 degrees. If I asked you around the nearest thousands and so on, then it would be 52.478 degrees. All of these degrees are rounded. So all of these degrees are, at some point, not 100% precise. The more precise your thousandths, 10,000ths, the more accurate your angle. But what you have to remember is that if you're going to represent your angle with the most precision, you could do it in minutes and seconds, and that would be basically the non-rounded version. So 52 degrees, 28 minutes, 41 seconds is the same as saying 52.4780555, and so on, no rounding. Which, if you're going to launch a missile and you want to hit the right target, you want to hit that target and not one of these wishy-washy ones that are rounded, because, you could hit the wrong ship. Another kind of question you're going to be asked to do in this week is to evaluate angles. So if I gave you a question and I said, what is the sine of 45 degrees? You would go to your calculator, pick it up, make sure it's in degree mode, do the sine of 45 degrees, look at your calculator, it's going to be 0.707, and so on. If I asked you to evaluate an angle, and I said the sine, this time, of 45.36 degrees. So it's a little more precise. And I asked you to evaluate, you pick up your calculator, you do the sine, 45.36 degrees. And the answer on your calculator should show 0.7115, and so on, 35677. You'd have to round if you're going to give me an answer to whatever place. So I'd say, find the value of the sine of 45.36, and I said the nearest hundredths would be 0.71, nearest thousands, 0.712, and so on. So the more values you give after your decimal, the more precise your angle. What I want you to recognize is this is an angle given in decimal degrees. There's another system, and the other system is to give the angle in very precise degrees and minutes and seconds. So, for example, you could be given the angle in your diagram, the sine of 45 degrees, 21 minutes, and 58 seconds. So you would first need to figure out what that angle was in decimal degrees first before you evaluate with the sine function. So by looking at the minutes, there are 60 minutes in a degree, so 21 minutes is less than half. So you should be able to predict that your answer should be less than 45.5, less than half. So to find the decimal equivalent, you need to start with the seconds. So there's 60 seconds in a minute, 60 minutes in a degree. So you would take your 58 and divide that by 3600, which is 60 times 60. Add to that the decimal equivalent of 21 minutes, 21 out of 60, and add to that the 45 degrees whole number. So 45 degrees plus each of these parts. So 58 divided by 3600 is 0.016111. 21 divided by 60 is 0.35, and 45 is 45. Add that all together, what you're getting is a degree that is now in decimal format, 45.366111 degrees. Now, you've done nothing to evaluate this in terms of the angle. You still need to find the sine of the angle. So the sine of 45.36111 degrees needs to be done yet on the calculator. All you've done is change the format of decimal degrees, which is precise, to or change the degrees, minutes, and seconds into decimal degrees, which is less precise, but still 45.366111 is very descriptive. To find the value of it, you need to use your calculator. So now you have to put the sine of that number. So go ahead and plug it in. The sine of 45.366 and so on is going to work out to be, you plug it in, 0.7116106. So whether you find the sine of the angle in decimal degrees or degrees and minutes and seconds, you still have to hit the sine function to evaluate it for the trig ratio. If you're good on your calculator, you will be able to enter degrees and minutes and seconds directly without having to change all the parts into decimal degrees. Hopefully you'll learn that in class. There's a button on many calculators that will say DMS, degrees, minutes, seconds. Some calculators will have the degree symbol, the minute symbol, and the second symbol. You need to figure out how to make that work. So typically you would do 45, hit the degree, minute, second button, 21, hit the button again, 58, hit the button again. That enters all three parts of the angle, and then take the sine of that angle in that format, and it should give you the 71116 without having to convert it to decimal degrees first. So it's your job to play with the calculator to convert back and forth. Another common question you're going to see is I'm going to give you the trig value. Say the cosine of some unknown angle is equal to 0.7789. So your job is to figure out what angle would make the adjacent over the hypotenuse equal 0.7789. So let's just say, for lack of any kind of creative math skills, in a diagram like this, I'm asking you to find the angle such that when you take the adjacent side, say it was 7789, divided by the hypotenuse, 10,000, 7789 divided by 10,000 is going to equal, as a decimal, 0.7789. But I still haven't asked or found a way yet with this to find an angle. So what are you going to do? Well, as you know, whenever you want to find an angle, you're going to have to hit second function. If you type in 0.7789, second function cosine, it's going to give you a value in decimal degrees. It's going to say 38.8400295. Now that might be very fine and well and fine depending on what the question is asking you to do. If it asks you to round your angle to the nearest tenths or the nearest hundredths, you could easily do that. So if it said the nearest tenths, you would just simply say theta is going to equal 38.8 degrees. If it asks you the nearest hundredths, then you would give an angle of 38.84 degrees. Now, if the question asks you to give the angle in degrees and minutes and seconds, what would you do? This is the first time we've had one of these. Going backwards from decimal degrees, this is called a decimal degree, a DD. We want to give the answer in degrees and minutes and seconds. So what we know for sure is that the angle is going to be 38 degrees. What we don't know is how that 0.8400 is going to make up a certain amount of minutes and a certain amount of seconds. So here's what we do. We take the degree portion away, 38. We're left with 0.8400295. That is the leftover component of the degree. Now we're going to take that and multiply it by 60. If we multiply that by 60, it's going to give us an answer, obviously, and that answer is going to be in minutes. So the calculator answer is 50.40177 minutes. That means out of the 60 pieces after the 38 degrees, we have 50 of those pieces taken up. That 50 is going to go here. And that 50 is 50 minutes. So 50 minutes. Now it's more than 50 minutes, in fact. It's 50.40177 minutes. So your job now is to take that 50 minutes away and look at what's left. What's left is 0.40177 of a minute. Let's multiply that by 60 to figure out how many seconds that we have. So 0.40177 times 60 is going to equal 24.10625. And that's the number of seconds. Now generally, 99.9% of the time, all seconds represented here, we round to the nearest whole number. So since it's 24.1, you would say 24 seconds. There. 24 seconds. So the original angle that we found way back at the beginning was 38.8400295. And that's the angle that we used for the first 2 weeks of trig. We didn't care, we just rounded it off to nearest tenths and nearest hundredths, whatever was required, and we moved on. Well, now we have one greater skill that allows us to take that angle that is and round it in a different way. And we're now rounding it into a format called degrees and minutes and seconds. The 0.8400, which is a portion of 1 degree, is represented as 50 minutes, 50 out of 60 minutes, and 24 seconds. Do another one of those examples. So say you were asked to give the angle, and you were told the sine of the unknown angle is equal to 0.96698770. You can work backwards. Now your job is to find the angle. So you plug that in your calculator, you know with all great certainty that to find an angle you have to hit second function. So you'll do the second function of the 0.9669877, and your calculator will give you an angle in degrees, and that angle is just simply not rounded, and you're going to get 75.2369 degrees. Now you look at the question, it's going to tell you to find the angle. Now if it's asking you for the nearest tenths, that would simply mean 75.2 degrees. If it asks the nearest hundredths, then you would have to round to 75.24 degrees. If it asked in nearest thousands, you would say 75.237 degrees. And the bigger the number of places after the decimal, the larger number of places, the more precise the angle. You could also be asked to represent the angle in degrees and minutes and seconds. So 0.23 of a degree is certainly about 1/4 of a degree. So we have 75 degrees for sure, an unknown number of minutes, and an unknown number of seconds. So we take away our 75, and we're left with 0.2369 of a degree. Multiply that by 60. That will give you the number of minutes, and that works out to be 14.214 minutes. So that whole number 14 is the number of minutes. So if I'm going to round that to the nearest minute, I would just say 75 degrees, 14 minutes. But if I want to give it the nearest second as well, I would take the 14 degrees away, and now I would do my seconds. And my seconds is found by taking the remaining decimal, 0.214, and multiply that by a further 60. So 0.214 by 60 is 0.84 exactly. It's a terminating decimal, it stops. Sorry, it's 12.84. What was I thinking? 12.84. So now we know the number of seconds. The question is, what do we do? We're asked to round, likely in the question, to the nearest whole second. So the 8 is going to round my number of seconds up to give us 13 seconds. And that's the precise way to write the angle in degrees, minutes, and seconds format. Last question we'll do here. Typical word problem. Say I had a question where the angle of elevation to a helicopter. And the angle of elevation to a helicopter is 67 degrees, 35 minutes, and 42 seconds. So now you have a very precise angle of elevation. And you are told that the distance from the spot where the observation is made to the point directly under the helicopter is 405 feet. Your job is to find the height of the helicopter. So you know the angle, and with respect to the angle, you are trying to find the x, which is the opposite, and you're given the adjacent to the angle. Therefore, that is going to require us to manipulate the tan ratio. So it's no different than the question we did before. The only thing different is it's now going to be a more complicated looking angle. The tan is 67 degrees, 35 minutes, and 42 seconds is going to equal the opposite of x over the hypotenuse of 405. And it's your job to rearrange the formula to solve for x. So you may want to go off to the side and convert the angle from degrees and minutes and seconds into a decimal degree first, and then multiply, because x is going to be found by taking 405 and multiplying that by the tan of the angle, 67 degrees, 35 minutes, and 42 seconds. But you're probably going to want to convert that angle into a decimal degree first. So you go off to the side, do your little calculation, you figure out that 42 seconds, so 42 divided by 3600, that's going to give you the portion of the overall angle that's seconds. So that's going to be 0.011666. And the 35 minutes is a 60th of a degree. So 35 divided by 60 is going to give you 0.58333. You add all that up with, of course, the 67. You're going to get 67.595. And that's another example of a non-repeating decimal. It happens to work out quite nicely. So all this gibberish changes then to the tan of 67.595 degrees. So on your calculator, you're going to type that in. That's going to convert it into a decimal. You have to use the trig function for tan. And when you multiply that value, that's actually equal to 2.425581. Multiply that by 405. And that's going to give you a value of 982.36 feet. That's the height of the helicopter. So my advice to you is not to get yourself too distraught by the angle written a different way. Just remember that there's 60 minutes in a degree and there's 60 seconds in a minute, or 60 seconds, 3600 for your overall degrees. Add them all up. You can also rely on your calculator if you know how to do it. If you don't, you might want to bring it down and ask me, and I will be glad to show you how it works. There's practice at the end in the trig for your exam or test. You should probably do some of that to make sure that you know what you're doing. Check your answers. Thank you.